Hello guys, today we're going to look at the repeated combination, pretty similar to repeated permutation, but a bit more complicated than it. And then we're going to see which type of permutation or combination to use from a given question. And we are done with counting the number of possible events with combination and permutation, and soon we will begin our next unit, possibilities with permutation and combination. Repeated combination. There's three different features that defines repeated combination. One is that it allows for repetition. It's just like the repeated permutation, but unlikely, the order does not matter in combination. The equation for repeated combination is NHR, and NHR, if you simplify it into a mathematical equation, it becomes n plus r minus 1 CR. So there's two questions here. Let's see which one to use the repeated permutation and which one to use the repeated combination. How many, if repeated, natural numbers of 3 digits can you make with 1, 2, 3, 4, and 5? So the question allowed you to repeat the usage of these 5 numbers. So that would mean we would do 5 times 5 times 5, which equals 125. And if we translated this into a permutation equation, then it would have become 5 pi 3. This becomes 5 powered by 3, which equals 125. So this one is a repeated usage of permutation, and this is because the order of 111 or the order the order of, let's say, 432 and 324 is different. The order matters from here. That's why we use the repeated permutation. Question 2. 8 identical papers are to be organized in 3 different drawers. So we have 1, 2, 3, 4, 5, 6, 7, 8 different papers. They're going to be aligned in 3 different, let's say this one's a triangular drawers. How many different methods are there to organize this? Now, before we solve this problem, I should really explain about the definition of NHR and how the theory works. But before that, we can see that we'll have to use the repeated combination because we're organizing papers into different drawers. We're organizing the same papers into just a different drawers. So, for example, if we say that this one, let's just differentiate this even though they're the same ones. So let's say we have first 3 blue and first 3 red. Let's say we put some in this rectangular drawer. Let's say we have 2 blues and 1 red. Does BBR and BRB or RBB make a differentiation between these 3 sets? No, it doesn't. All you need here is just what type of paper are you going to put in a different drawer. So that's why we use a combination here, repeated combination. The order does not matter. Now, let me clarify how NHR works. The definition of NHR is that from different sets of n, you allow repetition and you're choosing R. That's what NHR means. And NHR, if you change this into an mathematical equation, if you simplify it, as previously mentioned, it becomes n plus r minus 1 C and R. So now let's try solving the problem right now. So we had 8 papers which are to go inside 3 different drawers. So here n is going to be, from here n is going to be 3 and R is going to be 8 because you're allowing 8 different papers to be chosen in a different drawers. So think like this. To clarify N and R from the repeated combination, think that the big sets, the big different sets for here is the drawer is going to be N, and then the things that are differentiated, classified into different stuff, the things that are going to be chosen to go in either category they're going to be categorized in is going to be R. So the equation would be 3H8, which would become 3 plus 8 minus 1 C, and then 8, which would be 11, 10C8. 10C8, if you simplify, it would become 10C8 equals 10 permutation, 10 factorial, 8 factorial, 2 factorial, which would become 10 times 9 over 2, which is 45. That's how the question works. So let's solve some simple problems now. Now that we've learned how to calculate the repeated combination, let's try this problem. 3H5 equals a question mark. What would the question mark be? Let's try it. 3H5, R equals 3, N equals 3, R equals 5. So this would become 3 plus 5 minus 1, H5, which equals 8 minus 1 equals 7. This should be a combination. C equals 7C5, which equals 7 factorial, 2 factorial, 5 factorial, would become 7 times 6 over 2, which equals 21. So now let us organize which permutation and which kind of combination to use in a different situation. So starting with permutation, does the order matter? Yes. Can it be repeated? No, NPR does not. And let's see the repeated permutation. Empire, does the order matter? Yes, it's a permutation. Can it be repeated? Yes, that's why it's called a repeated permutation. NCR, does the order matter here? No, the order does not matter. Can it be repeated? No, not in NCR at least. NHR, does the order matter? No. Can it be repeated? Yes, it can be repeated. So when you're solving a problem, just think of this table and then see which one fits the best into the situation. Is the question asking for the answer that where the setup order of the set matters? If it's a yes, then choose either between permutation. If it's a no, choose either between combination. If the question allows you, if the answer is supposed to be repeated, the set of values which you are trying to get can be repeated, then choose NPR or NHR depending on the situation. If it's not, then use NPR or NCR. Thank you guys, and great job coming till here. If we compare our progress to a book, then we could say that we have finished the first chapter. The next chapter is going to be about applying the knowledge we've learned into a possibilities. So far, we've only, most of the times, handled the problems which ask you only the possible number of events. So next time, we're trying to adapt that into